637 says, in an experiment with a certain mutation of the fruit fly, N individuals were examined, and 20% of these were found to be mutants. Determine the standard error of the sample proportion of mutants if N is equal to 100. Okay, so in this case, in our sample, we observed 20% to be mutants. Okay, so in this case, we have to calculate this squiggle p. Okay, and the formula for squiggle p is going to be our count. Okay, so let me just backtrack here. So if we had 100 in our sample and our sample proportion was 20, that means the count is equal to 20. So we had 20 out of 100 fruit flies to be mutants. So in this case, our p squiggle is going to be y plus 2 over n plus 4. So in this case, we've got 20 plus 2 divided by 100 plus 4. So we get 22 over 104. And that comes out to be 0.212. Okay? And our standard error is now given by this formula, p squiggle times 1 minus p squiggle over n plus 4. So in this case, we got the square root of 0.212. 1 minus 0.212 is 0.788, I believe, divided by n is 100 plus 4, so divided by 104. And if you do this, you should get 0.040. Okay? And so in this case, the standard error is 0.040 for n equal to 100. For part B, we have n equal to 400. Okay? So in this case, the observed proportion is 20%, so that means our count, or our y, is 80. So 80 out of 400 flies being mutants gives us a sample proportion of 20, okay, of 20%. So our p squiggle in this case is going to be y plus 2 over n plus 4. So we've got 82 divided by 404. Okay, and 82 divided by 404 is 0.203. Okay, and so you can see in part A, p squiggle 212, it's a little bit more different from 20 than 0.203. So 0.203 is actually a lot closer to 0.20 than that one is. Okay, and the standard error is given by the same formula, square root of p squiggle times 1 minus p squiggle divided by n plus 4, and we get the square root of 0.203 times 1 minus that, so that's going to be 0.797 divided by n plus 4, so 404. And if you do that calculation, you get 0.020. Okay? And that also reflects the change that when you quadruple the sample size, the standard error gets cut into half.